This is Chapter 6-2, Properties of Parallelograms. Please copy your cuts. All right. There we go. All right, let's start with some definition. A definition. Come on, computer, keep up with me. All right, parallelogram. This is where we're going to start first. Come on, keep up with me, computer. All right, parallelogram. To begin, it's simply a quadrilateral, four-sided polygon that has both the opposite sides being parallel. So, as I just erased, I'm going to put back in. There we are. So, on this particular quadrilateral, the opposite sides will be parallel. That means that QP is parallel to RS. Okay, and also at the same time, QR is going to be parallel to PS. Okay, and this quadrilateral's name is PQRS. And again, as I stated, opposite sides will be parallel. Okay, so QP to RS and PS to QR. That's what a parallelogram is. So here's some further information about what a parallelogram is. Let's get into some theorems. Theorem 6.2, remember, it's not important to know theorem numbers, but to know their names and their functions. Okay? Starting with 6.2, a quadrilateral is a parallelogram that then if a quadrilateral is a parallelogram, then its opposite sides are congruent. So what does that mean? Okay? Remember, QP is going to be parallel to RS. If that's true, if this quadrilateral is a parallelogram, that means that QP is also equal to and congruent to RS. So PQ is congruent to RS, and also the opposite sides, SP is going to be congruent to QR. Okay? So they'll be parallel. And there will also be congruent to one another. Here's theorem 6.3. A quadrilateral, four-sided shape, is a parallelogram. If a quadrilateral is a parallelogram, then its opposite angles are congruent. So that means, again, here's my quadrilateral, PQRS. That means that the opposite angles will be congruent. Angle P is automatically congruent to angle R if this quadrilateral is called a parallelogram. And angle Q is congruent to angle S. So on a parallelogram, the opposite angles will be congruent to one another. Let me roll back forward with some of here. All right. And think of the word, when I say parallelogram, I'll scroll up one more time. When I say parallelogram, and we know it's a quadrilateral, four-sided polygon, when I say parallelogram, the key word right here to look for, look at the word parallel. So that automatically tells you that the opposite sides will be, or give you a hint that the opposite sides will be parallel to one another. Let's look at theorem 6.4. If a quadrilateral is a parallelogram, then its consecutive angles are supplementary. That means what? On my quadrilateral PQRS, that means, first of all, we need to recall opposite angles are congruent. So P and R are congruent, and then Q and S are congruent. But this particular theorem 6.4 says that consecutive, you need to remember consecutive means next to. Angle P plus angle Q is equal to 180 degrees. The measure of angle P plus the measure of angle Q is equal to 180 degrees. That also means that Q and R are consecutive and next to one another. The measure of angle Q plus the measure of angle R is equal to 180 degrees. Okay? And I know that because these two, if we recall, opposite angles are congruent. So if that's true, these two added together, Q plus R, will be congruent. And again, because P and R are congruent, that also means that Q plus P will also still be equal to 180 degrees. And also, the measure of angle R plus the measure of angle S because they're consecutive or next to, in other words. When I add the measure of angle R plus the measure of angle S, it will equal to 180 degrees. And then P and S, or S and P, these two are next to one another. So the measure of angle S plus the measure of angle P will also be equal to 180 degrees. Consecutive angles next to. These two added together, Q plus P is 180 degrees, or I can do P plus S is equal to 180 degrees, or I can do measure of angle Q plus the measure of angle R is equal to 180 degrees, or again, I can do the measure of angle R plus the measure of angle S is equal to 180 degrees. Right? Some other information about quadrilaterals being parallelograms. If a quadrilateral is a parallelogram, then its diagonals will bisect one another. Remember, diagonals means from corner to corner on the diagonal P to R. That's one diagonal. And from Q to S is the second diagonal. Here's what's so beautiful about diagonals on a quadrilateral that's a parallelogram. If I draw the diagonal from Q to S, that automatically means that Q, if I go to call the midpoint M, QM is the same exact length as SM. So when I take the diagonal, these two segments will be congruent. Similarly, when I take the diagonal of PR, that means PM is congruent to RM. These two segments are congruent. Okay, and again, the intersection I'm calling M. Okay, so QM is congruent to SM, and PM is congruent to RM. Okay, so let me draw that. I want to draw that just one more time here. If I have a parallelogram, we'll say it is so, because I know the two opposite sides are parallel. If I have A, B, C, and D, we'll call that D. If I draw the diagonal there from A to C, and then I draw a second diagonal here from B to D, we know the two line segments will intersect right here at some point. I'm just going to call that point M for a point name. Well, when I have an intersection point that have a special thing that happens, A to M will be congruent to C to M. And when the diagonals cross or intersect, that means from B to M, it will be congruent to D to M. Okay? Now, that does not mean that AM is the same length as BM. It has to be on the same diagonal. So AM corresponds to CM, and BM corresponds to DM. And again, I don't go DM and CM. They're not. DM is not on the same segment as CM. Right? Next item of business. Let's suppose I have this particular figure here. It's from your book, page 331. Let's say I have parallelogram PQRS, and I need to find the measure of angle R given the measure of angle P. Well, first of all, let's look at this here. If it's a parallelogram, the two opposite sides are congruent. That instantly tells me that the opposite angles are congruent. So I can immediately find the measure of angle R. It has to be congruent to angle P, which is also 70 degrees. Opposite angles of a parallelogram are congruent. Now I need to do B. Just done A. R is equal to 70 degrees. Oops. Equals to 70 degrees. That's what that's supposed to say. And then let's do B, the measure of angle Q. What do we remember? Consecutive angles on a parallelogram are supplementary. Therefore, this angle P plus the measure of angle Q will be equal to 180 degrees. And here's that being shown. The measure of angle Q plus the measure of angle P equals 180 degrees. And when I work that out, I'm going to substitute any of the measure of angle Q. I'll just call that X, plus the measure of angle P is 70 degrees, equals 180 degrees. Subtract 70 on both sides. X is equal to 110 degrees. So that means the measure of angle Q is equal to 110 degrees. Let me erased it so we can see example 3. Which takes us down to example 3 in your textbook on page 331. Suppose I have this parallelogram PQRS. Find the value or measure of, find the value of x. Pretty simple to do. First of all, we need to know that P, because it's a parallelogram, that means that PQ is parallel to RS, and QR is parallel to PS. And because we know that information, what else do we know about parallelograms? We know that consecutive angles must equal 180 degrees. So that means the measure of angle P plus the measure of angle S has to equal 180 degrees. And by substitution, the measure of angle P is 3x degrees plus 120 degrees equals 180 degrees. Subtract 120 on both sides. 3x is equal to, I'm left with 60 here degrees. Please don't ask where I got the 60 from. Subtract 120 on both sides. That's Algebra 1 skill. Okay? Make sure you remember that. Divide both sides by 3. X is equal to 20. So now I have the value of x. And there's your 6-2 lesson.